Question 14. A function is given by f of x equals 18x² minus x to the power of 4. Part A. Find the stationary points and determine their nature. Find stationary points by solving the equation f' of x equals 0, where f' of x represents the first derivative of the function f of x equals 18x² minus x to the power of 4. So differentiating the right-hand side with respect to x, we get f' of x is equal to 36x minus 4x cubed. So we're going to solve for x the equation 36x minus 4x cubed equals 0. We can simplify this equation by dividing all terms by negative 4. And we end up with x cubed minus 9x equals 0. Factorising out x from both terms on the left-hand side, we get x times x squared minus 9 equals 0. Recognising that x squared minus 9 is a difference of two squares, and we can factorise x squared minus 9. So we end up with x times x minus 3 times x plus 3 equals 0. So stationary points exist at x equals negative 3, 0, and positive 3. The next step is to find the y-coordinates and the nature of the stationary points at x equals negative 3, 0, and positive 3. And I've summarised the findings in this table. So this is the table of gradients. The first row are x values, the second row are y values, and the third row are gradients, or the value of the gradient at those x values. So at x equals negative 3, 0, and positive 3, these are our stationary points. The y values are 81, 0, and 81, and we get those by substituting x equals negative 3, 0, and positive 3 into the original function, that is the function f of x equals 18x² minus x to the power of 4. And to get the value of the gradients around the stationary points, we use the first derivative, f' of x equals 36x minus 4x cubed. And we end up with these values. So notice that around the stationary point where x equals negative 3, the gradient's positive here, negative here, which means that this stationary point is a local maxima. This stationary point here is a local minima because the gradient on the left-hand side is a negative, the gradient on the right-hand side is a positive. And at x equals positive 3, this represents a local maxima because the gradient on its left is a positive and the gradient on its right is a negative. So from the table, the stationary points at negative 3, 81, 3, 81 are local maximums, and the stationary point at 0, 0 is a local minimum. Part B. Sketch the curve, labelling the stationary points and axis intercepts. Firstly, the y-intercept equals 0, as this corresponds to the y-coordinate of the stationary point that we found in Part A. To find the x-intercepts, we need to solve the equation f of x equals 0. That is, 18x² minus x to the power of 4 equals 0. Factorising out x squared from both terms on the left-hand side, we get x squared multiplied by 18 minus x squared equals 0. Factorising 18 minus x squared as a difference of two squares, we get x squared times 3 root 2 minus x times 3 root 2 plus x equals 0. Hence, x-intercepts exist at x equals negative 3 root 2, 0, and positive 3 root 2. So here is a sketch of the graph of f of x, or y, equals 18x² minus x to the power of 4, taking note of the three stationary points that we found in Part A, and also the origin represents the x and y intercept. But the other x-intercepts at negative 3 root 2 and positive 3 root 2 are shown here as well.